calorimetry. So the name of the chapter is calorimetry. So the chapter is calorimetry, and this is basically related to heat. You have already studied about the various aspects of the heat. We studied heat as a form of energy. You studied the different modes of transmission of heat. Now we are in this chapter. We are basically concerned with the different measurement, how the heat can be measured. Okay, and then the various principles related to it, and then the state transformation, that is from solid to liquid, liquid to gas, and vice versa. All right, and the various terms related to this measurement of the heat. Okay, so first of all, when we are talking about the heat, there are two concepts which come into our mind. One is of the heat and one is of the temperature. For a layman, it might be like heat and temperature happen to be the same thing, but since you have a background idea of the heat, so for you it should not be the same. As far the heat is concerned, we will first study the concept of this concept of heat, and then we'll deal with the concept of temperature. Now we all know that if we are talking about any substance, what substance is made up of molecule, we'll study on the basis of molecule, not up to the atomic level. Okay, now we all know that molecules possess two type of energy, that is the kinetic energy. This is possessed due to the motion of the molecules, random motion of the molecule, and another is your potential energy, which is due to the position or the attractive force of the force between the uh, molecules. Now you say how attractive force? Attractive force, due to the presence of the attractive force, what happens? They are at the different positions, and since they are at the different positions, so you can say the position and the shape of the molecule of the substance has been given, and because of this too, we can say that a molecule or a substance possesses the sum of kinetic energy and the potential energy. This kinetic energy, that is together, if I give it a new name, or a new name is given to it, in a simple term, instead of telling kinetic energy and potential energy, we can call it together as internal energy. So now when we are talking about internal energy, we mean by the kinetic energy and the potential energy of the molecules. Okay, kinetic energy and the potential energy together in the substance. All right, now let us try to define heat. So when we come to the concept of heat, okay, it has been considered that it is the internal energy of the molecule constituting the body. Okay, so when we are talking about the heat, it is the total internal energy of the molecules, total internal energy, okay, of all the molecules molecules of a substance. heat of the body is basically been defined as the total internal energy of all the molecules of the substance. So if I'm talking about the heat of our body, the total molecules which are present in our body, the total internal energy of our body will be called as the heat of a body. If I'm talking about the heat of a heat present in a water, or heat present in copper, or heat present in any other substance. So what we mean by saying that the total sum of energy which is present, that is called as heat of the body. Clear? So whenever we are talking about the heat of a body, we are talking about the total internal energy, that is the sum of kinetic energy and the potential energy. And when we are talking about the heat can be considered as a measurable quantity. It is a measurable quantity. That means we can measure the amount of heat present in the body. Quite often you may have studied, especially if you are taking any food item, the total number of various nutrient values have been given. And if you see, these nutrient values are given in the form of the heat which it can generate, or heat energy which it can provide. All right. So if you are drinking, or if you are using a any beverages, or you are using, so everywhere you will find how much protein is present, carbohydrate is present, vitamins are present, and other things. But the value which has been given, that means it is a, that is given in terms of the heat which it can generate in your body. All right. Now, so if we can measure this heat, okay, so the branch of the physics which deals with the measurement of the heat is basically called as calorimetry. Metric. It is the measurement of the quantity of heat energy. Measurement of the quantity of heat. When I'm writing down heat, it means heat energy. All right. So I hope the concept of heat is clear to all. So we come to some other uh, terms which are related to heat. If we are able to measure the heat, okay. So what are the system which we can use to measure it, or what are the units in which we can measure? Because any physical quantity, if we are measuring, we are required to mention its unit, unless until it is a pure ratio. So the unit of heat, if we are talking about the SI unit, this is joule, presented by J as usual. All right. But there is an exclusive unit of heat which we call it as calorie, represented by CAL. Okay, that is 1 degree is not 0 to 1 degree. It is to 1 degree. Change in temperature. Change in temperature is of 1 degree. Then the amount of heat energy absorbed is called as 1 calorie. And once again, I'll Fine. Is it is the heat required to raise the temperature of 1 gram of water 1 gram of water through 1 degree centigrade. Now the range in which the temperature is been raised, that is of water, for the definition point of say, that is 14.5 to 15.5 degrees centigrade. This is generally the room temperature which has been taken. Now there can be any range of temperature, but for definition we require to have a range of temperature that is 14.5 to 15.5. All right, that is 14.5 to 15.5. Now why this is 14.5 to 15.5? So 14.5 to 15.5 has been considered because at the different temperature ranges, it was found that during this temperature range, where the variation in the amount of heat which has been absorbed, that is minimum. Now what I mean by variation? Variation means say what we can say it as uh, a characteristic error which we can have. Okay, maybe 1 degree centigrade to 2 degree centigrade, it may be different. Okay, the amount of heat energy which is absorbed may be more, or and within the different temperature ranges, it is observed that between 14.5 to 15.5, there it is the minimum quantity of heat which has been absorbed by the water, and therefore scientifically or experimentally it was observed, because for the definition we require to have a standard value, and therefore this amount of energy which was absorbed between 14.5 to 15.5 was considered as for the definition, for taking the definition of, for defining the 1 calorie of heat energy. So the amount of heat energy which has been absorbed by the substance, by the water, by 1 gram of water to change its temperature through 1 degree centigrade, that is from 14.5 to 15.5 degrees centigrade, is called as your 1 calorie. Alright, so this was the definition of calorie. Now we have the higher units of the calorie and lower units of the calorie. So what if we are having the unit as calorie and a unit, so we have calorie also as a unit, and we have joule also as an unit. This is your SI unit, whereas the upper one is your simple unit. So there should be a conversion factor. Now 1 calorie of heat energy is equivalent to 4.186 joules of energy. That means if you have to convert joule into calorie or calorie into joule, this is the relation. For our convenience, for the convenience of the calculation point of view, we can also write 1 calorie is equal to 4.2 joules. Okay, which means that to increase the temperature of 1 gram of water from 14.5 to 15.5, the amount of heat energy which is taken, that is 4.2 joule, or is equivalent to 4.2 joule, or we call it as 1 calorie. Similarly, higher units also we have 1 kilocalorie, and 1 kilocalorie will be equal to 10 to the power 3 calories, and 1 kilocalorie will be nearly equal to 4200 joules. One kilocalorie will be equivalent to 4200 joules. Multiply with 10 to the power 3. That is what you will get. So you should be able to define. Now 1 kilocalorie, when we are defining, we will take the water. The mass of water is taken as 1 kilogram. The temperature range will remain same. That is 1 degree. Delta T will be equal to 1 degree centigrade or 1 Kelvin. You can also use Kelvin. Okay. And temperature is 14.5 degree centigrade to 15.5 degree centigrade. Clear? So I hope the concept of heat is clear to all of you. If you have any problem, you can raise your hand. Meanwhile, I'll admit. Please be on time. You come to the waiting room before what happens when we are trying to define, okay, and various temperature ranges have been taken. Okay, so it was found that the variation, which the experimental variation which was given, that is least for this 14.5 to 15.5. Yani chances of error is least in this range. But others, what happened, there will be a greater error chances, and therefore that range is not been taken. Although if you actually calculate the value, it goes to the 4th or the 5th decimal place. So in the normal case it is negligible. Okay, but still when we are comparing the various temperature range, it was considered that this temperature range has got the minimum variation. That means minimum chances of error will take place, and that is why if I am defining 1 calorie, okay, so between 14.5 to 15.5, 1 gram of water, the amount of heat energy which it will be taking, that is the fixed amount which is going to be considered as 1 calorie. Okay? Okay, mute yourself.
Sir, sometimes your voice doesn't come only, sir.
Maybe the mic might have gone here and there.
No?
And this concept of temperature. All right. Temperature is another important and fundamental physical quantity. All right. Now, you might have studied the definition of temperature in the lower classes, a degree of hotness or coldness. So, what does that temperature tells us? The temperature tells us the state or thermal state of the body. So, temperature basically tells us the thermal state of the body. I'll give you the notes also of this. Okay, so it is basically a parameter which defines the thermal state of the body. Now it might be like a body. Now thermal state means there will be a hot body and a cold body. Keep in mind, hotness and coldness are relative to Earth, okay, to the surrounding. One body may be hot with respect to the another. The same body may be cold with respect to the. Okay, so for example, if I am touching the table, if you touch the table seems to be cold. Okay, but when you touch a hot tawa, okay, what will feel? Tawa feels to be hot. The temperature of your body remains same, but still you are able to feel this coldness and hotness. The difference is in terms of the energy transfer which taking place, which also call it as it determines the direction of flow of heat energy. Okay, two bodies at different temperature might be having the same heat. Two bodies having the same heat might be at a different temperature also. Okay, and two bodies having the same temperature might have different heat also. So when we will study in detail, you will be able to make out the various factors which can alter the heat of the body, while it may be like the temperature is same or the temperature may be different. So we have two thermal state of the body, that is hot and cold body. So heat temperature basically is a parameter which tells the thermal state of the body, that is the degree of hotness or coldness. It determines the direction of flow of heat when the two bodies at the different temperature are placed in contact. Now for example, I take this red body, then I take this yellow, and then I take this white. From the color, red is hot, yellow in between, and white is least. So now if you try to observe the heat flow, if you keep these two bodies in contact, let me mention them. Let it be dr, dy, and temperature of white. Temperature of red is the maximum, temperature of white is the minimum. So now if we consider the heat flow, you'll find that the heat, if I keep the red and yellow in contact, we'll find that the heat will be flowing from red to yellow. If I keep these two in contact, yellow and white, the heat will be flowing from yellow to white. So in this case, if you observe, in these two cases, the heat flow is from red. So that means this was hot, this was cold or lower temperature. But when we consider these two cases, okay, now this is considered to be cold and this is considered to be hot. So what I mean to say is that the thermal state of a body, that is the temperature of the body, is a relative thing. Okay. So if we define the heat or the temperature of the body, the temperature is a parameter which tells the thermal state of a body, that is degree of hotness or coldness of the body. It determines the direction of flow of heat when the two bodies at different temperature are placed in contact. Okay, so this is about the temperature of the body. And when we are talking about the temperature of the body, in terms of internal energy, we can say that it is the average internal energy of the body. Okay, that is called as your temperature of the body, and in particular the kinetic energy, the average kinetic energy. Okay, so now we move to the unit. The unit of temperature. The unit of temperature, the SI unit of temperature is said to be Kelvin, denoted by K. So we will be using the Kelvin as an SI unit. There are other normal units which we are using, that is degree centigrade and degree Fahrenheit. So if we try to take the temperature in degree Kelvin, and we have to change it to Kelvin, the temperature is in degrees centigrade, this is the relationship. Temperature in degree centigrade is equal to 273 plus T degree centigrade. Okay, this is in particular. So suppose if I have a temperature of 5 degrees centigrade. So in Kelvin, this will be equivalent to 278 degree. Sorry, not degree. Degree is not mentioned. 278 Kelvin, A capital. Name of the scientist should always be mentioned as capital. Clear? Now, if I try to find out the change in temperature, suppose if I am having a temperature 5 degrees centigrade and another temperature 0 degrees centigrade. So if I have a 0 degree centigrade, this is 273 Kelvin. Now I want to find out the change, delta T. Here the change is 5 degrees centigrade, and here the change is also 5 degrees centigrade. 5 Kelvin. So what does this mean? Let me put this down. So what does this mean? In particular temperature when you are changing, okay, that will be changed according to 273. But change in temperature in degree centigrade is equivalent to change in temperature in Kelvin. So the change in temperature, that is the difference between the two temperature in degree centigrade as well as in Kelvin, they are equal. So if we are mentioning the change in temperature, we can mention, we do not require to change the unit from degree centigrade to Kelvin or Kelvin to degree centigrade. They can be automatically changed. Then we have the other relationship. This is C by 5 is equal to F minus 32 upon 9. Alright, this is between degrees and now while dealing with the, what is this 273? 273 degrees centigrade is equivalent to 0 Kelvin. Degree centigrade is equal to 0 Kelvin. Okay, and sorry, minus 273. Sorry, not 273, minus 273. Because if you see, T in K is equal to 273 plus temperature in degree centigrade. All right. So if I add 273 plus minus 273, we get it as 0 Kelvin. Now this minus 273 is called as absolute zero. You might have studied in chemistry. This is called as absolute zero. Alright, this is the temperature at which it is considered that the motion in the molecules will cease. And this is graphically been achieved. Actually, no temperature can reach up to minus 273 degrees centigrade or absolute zero. Okay, but when you plot a graph, then you get this as minus 273. Okay, so we quickly summarize the difference between the heat and temperature. So heat is a form of internal energy. Temperature is that parameter which determines the direction of flow of heat. The SI unit is joule. The SI unit is joule, SI unit is Kelvin. This is measured by the principle of calorimetry. Of tree. Here it has been measured by thermometer. Two bodies may have same heat but different temperature. Same heat, different temperature. And here, same temperature, different heat. Okay. Now, and when the two bodies are placed in contact, the resultant is equivalent to the sum of the individual heat of the individual bodies. Okay. So if Q1 and Q2 are there, then when they are being kept in contact, so resultant Q will be equal to the sum of this heat. Where here, if we have got two temperature T1 and T2, then the resultant will be, say, TR, which is going to be less than T1 but greater than T2. Okay, so that will be lying in between. So these are some of the differences between heat of the body and temperature of the body. Now we come to the next term. Factors affecting the quantity of heat absorbed to increase the temperature of the body. I hope up till here it is clear to all of you. Any question? Yes, Ashutosh. Ashutosh Kumar, unmute yourself. Ask your problem.
Sir, please take Ayush and the class.
They all are too late. Now I will not allow them. It's going to be over now.
अरे सर ले लीजिए सर.
अरे बेटा कितने दिनों से ये चल रहा है, जब देखो तब हम लास्ट मोमेंट तक लेते रहते हैं.
ले लीजिए सर, आखिरी बार कर दीजिए.
सर
क्या करें.
हाँ मैं
Excuse me. Sir, can you please explain why two bodies can have same heat but different temperatures?
Yes, I'll explain you. Just let me
Sir,
clear with the
sir,
once.
sir, why can't we reach at absolute zero degrees?
Before reaching to the absolute zero, the entire motion of the particle is considered to be stopping. No motion will take place. No
Sir,
motion means no internal energy, and practically it is not possible to have a zero internal energy. Okay,
so
kinetic energy भी zero हो जाए, potential energy भी zero हो जाए, that is law of conservation of energy तो obey नहीं होगा ना इस केस में.
Yes, sir.
इसलिए theoretically it is been achieved, practically it has not been achieved. Okay?
Okay, sir.
Okay. Ayush Shah is not coming through the proper channel. The attendance is less. That's factors affecting the quantity of heat. This chapter is basically related to the heat of a body. So now we are going to study about the factors which are affecting the quantity of heat energy absorbed. Absorbed or evolved, okay, to increase the temperature. Three major factors which affect. The first is the mass of body. The second one is increase in temperature or change in temperature. That is delta T. Mass is denoted M. And third is the nature of the material of the body. Or the substance. Okay, so we'll deal with each of them one by one. Okay, the first one, mass of the body. Mass of the body. The amount of heat energy absorbed is directly proportional to the mass of the body. Q is the amount of heat energy absorbed, directly proportional to mass. The Q will be representing the heat of the heat energy absorbed or evolved. If pressure is increased, it is absorbed. If temperature is decreased, it is evolved. Directly proportional to the mass of the body. Very simple to understand. If the quantity of heat energy, the mass of the mass of the body is more, it will take more amount of heat energy. It has got the capacity to absorb more amount of heat energy. If the mass is less, it has got lesser capacity to absorb the heat energy. All right, and you might have observed boiling of water. Okay, if you take 1 liter of water and boil, and you take half liter of water. Okay, so 1 liter you can multiply with its density, change it into, and then you can get the mass. Point is that 1 liter and half liter, you all understand there will be change in the mass of the body. So 1 liter will be taking more time to absorb. Okay, because it has to take more heat energy. Half liter will get boiled fast because it has to take lesser amount of heat energy. Got it? The next factor is the change in temperature, increase in temperature. That is delta T. Here also we find that Q is directly proportional to delta T. Say from 0 degrees centigrade, I have to increase it to 15 degrees centigrade. And from 0 degrees centigrade, I have to increase to say 50 degrees centigrade. Definitely keeping the mass same. Okay, so for 50 degree it will take more time. More time means more energy it has to absorb. Okay, whereas for 15 degree, 1.5, it will take less time because less energy has to be absorbed. All right. Now, the third factor, that is the material of the body. Now, material of the body means the nature of the material, of what it is made up of. Okay, it is very important factor which determines the amount of heat energy which it is absorbing. Okay, you take again an example at your home. Water, you take same amount of water and same amount of milk. All right, you increase the temperature also through the same amount. Say from 15 degree to say 50 degree you have to increase. Normal temperature 15, nowadays it might be 25 degrees centigrade approximately. So the both will be a little bit low. You will find that one of them will be boiling fast and another will be taking time to boil. Why? The nature of the material of which it is made up of. Okay, so we find that objects of the same mass but made from the different substance absorb different amount of heat energy to raise the temperature by the same amount. Okay, now how to know the specific the nature of the material? How can we calculate that? Nature of the material of which it is made. This has been calculated by a special term factor. We call it as C, specific heat capacity. Now, specific heat capacity for different material is different. Copper it is different, water it is different, ice it will be different, and accordingly they will be taking up the heat and giving out the heat. Okay, so accordingly they will be taking. Now it has been considered that the water has got the highest specific heat capacity. So that means for the same mass of water and the same temperature you have to increase, the water is going to absorb more amount of heat energy as compared to say copper. If you are taking, say if I take 50 grams of water and 50 grams of copper, I increase the temperature from 15 degree to 50 degree. Here also 15 degree to 50 degree. You will find this will get heated faster. This will take time to get heated up. Alright, which means that this is absorbing less amount of heat, this is absorbing more amount of heat. So for the same temperature range, same amount of heat, one is taking more time, one is taking less time. One is absorbing more heat, one is absorbing less heat. Okay, so I hope Mayank your question has been answered. Okay, because it is depending, the amount of heat energy is depending upon the various factors. Therefore, we find that either of the two factors remaining constant, the third is going to determine the change in the amount of heat energy. Okay, so if mass is constant, the temperature and nature is going to determine. If temperature is constant, then mass, temperature means change in temperature, then mass and nature, and if nature is constant and temperature is constant, then the mass will be determined. So if I combine these factors in the form of mathematical expression, we get Q is directly proportional to M, Q is directly proportional to delta T. If I combine it, we get Q is directly proportional to M delta T, or if I change the proportionality to equality, I use a constant, and that is nothing but C delta T, where C is the specific heat capacity, delta T is the change in temperature, M is the mass of the body. Okay, so this is the first formula which you can use to find out the heat of a body. That is, either the heat is evolved or heat is absorbed. Okay, the change in temperature will only be the difference from higher to lower. So if initial is higher and final is lower, you will find that it is cooling, heat is given out. And if initial is lower and final is higher, it will be giving you that the body is absorbing the heat energy. Okay, what I mean to say is that if I have Ti as initial and Tf as final, so if initial is less than this, gain Q is going to be gained, absorbed. If Ti is greater than Tf, then loss, heat is being lost. So I hope up till here it is clear to all of you. Any question? Raise your hand. No questions? All the things are clear up till here? Yes, Parth. Unmute yourself. Parth, Kesri. Yes, what is the problem? Say.
सर ये जो फॉर्मूला सर दिया हुआ है Q इज इक्वल टू CM डेल्टा T, सर इसमें सर मैं नेट इस वक्त नहीं चला था सर, उस वक्त जो आप C, सर इसमें C क्या है?
C is a specific heat capacity. All right, it's basically when you are combining, Q is directly proportional to M and Q. So proportionality sign, when we change, so we change to equality, we replace it by a constant of proportionality. Now here the constant of proportionality is C. which is called as the specific heat capacity. All right. Why it is constant? Because for different material, C is going to be constant. That is why we call it as a constant of proportionality over there. And this basically represents the nature of the material of which the substance is made up of, which is the third factor which determines the amount of heat energy absorbed or evolved, means taken or given out. I hope thing is clear. Okay.
Yes,
Then
sir.
mute yourself. Mute yourself. Yes, Mayank.
Sir, you told that we can't reach the temperature of absolute zero. Sir, if we
Yes.
can't reach that temperature, then how can we say that the molecular motion will cease at that temperature?
See, experimentally it has been found. Okay. See, there is a graph which has been drawn between the temperature and the velocity. Okay. If you try to see, search, you will get it. And even in your chemistry also, you might get this, where you have been explained about the absolute zero. Okay. The graph is somewhat like this. So here we have the temperature. The graph comes like this. As the temperature increases, the velocity increases. Now when you start moving the graph towards the negative side, all right, this is the point which we get it as minus 273 degrees centigrade. Now if the graph touches this point, which means that the velocity at this point becomes zero, okay, or the kinetic energy becomes zero. So that is how it has been determined that at this point the kinetic energy will become zero, which means that the entire uh, velocity of the particle will become zero, because mass is not going to be zero. Kinetic energy, there are two parameters, mass and velocity only. Okay, so mass can't be zero. So what is the parameter which is going to be zero? Velocity. So that means the motion is going to cease.
Okay, sir. Thank you, sir.
Clear? So this graph you will get it. Okay. So I hope up till here it is clear to all of you. So for today I am uh, closing the topic. Next turn I will be telling you about the thermal capacity, the specific heat capacity, okay, then calorimeter and the principle of calorimetry, okay, with the natural consequences. If you have any question, you can raise your hand, you can ask. Okay, so nobody is having any problem, any question from anything else? I hope you all are completing your work up to date, practicing your numericals, practicing how to write down the answer, although this time the test is objective. Okay, but in boards you have to write down the answer, so practice as much as can. Okay, once we finish off with the course, then we'll start with the revision work, and the practice we will do it online also, we'll try to do. Okay, but you keep yourself appraised with the changes and the other things. In this chapter there is nothing to be left out. Okay, everything is there in the syllabus. Okay then, anybody having any question? I hope all of you have submitted. I don't find everybody. The attendance is much better as compared to the first project, but still there are some who have not submitted till now. So very soon I will be putting the list. So don't tell me that I have submitted and my name is not there or is there. So okay, then we finish off with the class. Bye for now.
Goodbye, sir.
On गाना गाता है।